Hello everyone, welcome to today's course. Today we'll talk about loops. Here is a short outline of the topics that we will discuss today. So we'll introduce the syntax of the two typologies of loop, while and for, and the inner use of these loops with break and continue, and alternative to the conditions with else and the nested loop. So basically, what is a loop and why do we need it? Basically, when we have a set of instructions that we need to execute for several times, and they are the same set of instructions, we cannot write these instructions again and again and again in a list. Though we make use of the iterators and the loops in order to execute this set of instructions over something, basically over some data. So we have same instructions over different data. We have two models to use loops, and that we will be introduced in this lesson: for loop and while loop. The for loop iterates over a set of values or a range of values, and for each element of this value, it executes some instructions. It starts from the first element, it executes the instruction, then it picks up the second element and executes the instructions, and then the third, and so on, till it reaches the end of this list. Once the list is empty, the for loop breaks, so terminates. This is a short introduction of the syntax. So we have the beginning of the statement with the for keyword, a variable, which will be used to store one by one the elements of our list, and the range of values. Then the body of the for loop, which in this case is just a print. So we are just printing the value of the element that we are considering. What we can use as a range, as we have already introduced in a former lesson, strings are to be considered as arrays, array of characters. So a string can as well be a set of elements, a sequence of characters, like hello message is a sequence of the elements H, E, L, L, O, space, M, and so on. It can be an explicit set, like colors, in this case, red, green, and blue. So it's a sequence of different values, in this case, strings. Or we can define ranges of numbers. We have a method called range that takes in input 1, 2, or 3 variables, and that generates a sequence. So in the first case, range with a single input variable will generate a sequence of numbers from 0 to n-1. So if we write range 5, it will produce 0, 1, 2, 3, 4. Why from 0? Because, and why not from 1 to 5? Basically, this comes as an approach that has been used in many other programming languages, where for arrays or for sets, the first element is to be considered the element 0. That's why, while counting or while referring, in the future will be introduced to arrays, so and you will have indexes, but while referring to elements, we start from 0. This is as well the reason why these methods, while generating numbers, it starts from 0, and in order to generate 5 or n numbers, it needs to reach only n-1. In case we provide an input 2 numbers, means that we are asking this method the starting and the ending point. So it will, in the second example, we are ranging from 5 to 10, and the execution will be, the output of the execution will be 5, 6, 7, 8, 9. because we're indicating the starting point and the ending point of our range. The former to increase the number by 1 automatically without any explicit information. The third syntax, it asks as well whether we want this step of incrementation to be different from 1. The 1 is the default one, so if you omit it, it is 1. In other case, if we want to write a different step, we may write a third element, like in the case of third example, 5, 10, 2, mean from number 5 to number 10, increment by 2. So if the output will be 5, 7, and 9. So from the first element, 5, it will continue by incrementing by 2, so 5, 7, 9, and it will stop to number 10 minus 1, because the range is this n minus 1. Just let's have a short example. So for I or either in range, let's say 7, we are just printing out the value of I. Sorry, ether. And as you can see, it is 0 from 6. Or in case, this is a way to generate the sequence of numbers instead of writing 1, 2, 3, 4, 5. But instead of a sequence of numbers can be a sequence of text. Like iterate over A, B, C, and it will just print in the standard output. These are elements, so the important is that for loop iterates over elements. These elements can be explicitly declared, like in this case, A, B, C, D, E, or any other text, or generated automatically, because the common use of for is to iterate over a set of times, and instead of writing, because it will be quite not dynamic and a waste of time writing 1, 2, 3. Python comes into help with a method called range, where we just set the number, and it will automatically generate this list. But what is important is that for iterates over the elements. Why we may need it? For example, suppose that we have some numbers. Let's do an example. 17, I'm taking some random numbers that come into my mind. Suppose I want to calculate the sum of these elements. I have 4 elements, and to these 4 elements, I know the values. So 7, 17, 98, 101, 101. And I want to make the sum of these numbers. So sum equals to ether. You know that this is shortened index syntax of something more explicitly written, like sum equals to sum plus a variable. It works fine except for the first case, for the first iteration. Why? For the first iteration, we will have 7. Sum equals to a variable so far not declared and not initialized, plus 7, the first number. Though, do not forget, when you make use of a variable, that variable should be initialized to some value. In this case, 0, because we want to calculate the sum of these variables. So So far we have nothing. Then for the first iteration, it will be 0 plus the first element. Then print sum. Pay attention to the indentation. Now, if I run it, it says 223. If by mistake write some tab or space, I will have this effect. Why? Because print will be part of the for loop and will execute for every iteration. I have 4 elements, 4 output, 4 time a print, an incremental print. So the print of the incremental sum, because the first time is just 7, and the second time is 24, because it's summing the first 2, and the third time the sum of the 3 elements, and so on. But beware, always pay attention to the indentation. Do we need to print every time the current value? Most probably no. So I can say that the most correct syntax is by printing at the end. If you wish to print it every time, you are free, but pay attention to the indentation and the dependency that you are creating with the instructions. Okay. While loop has a different approach. It does not consider a set of values. It considers a condition. So it iterates until a condition is true. We use while loops when we do not know a priori the number of elements that we have to process. Because if we knew it, and if we knew as well the values, we could have used the for loop. But for the while, we use it under the condition that we don't know how many and which are the elements, basically. But while by explicitly setting a condition, the condition obviously should be parametric, should depend on some variables. And these variables should be declared and initialized before the while, because under those conditions, I will check whether to enter, to execute the first instructions inside the while, and obviously update it. So let's see an example with the syntax of while. So there is the keyword while, the condition under which it will continue, it will keep on looping, and the set of instructions, like simply just printing out some value and updating the variable under which I have the condition. If I by mistake skip it, I will remain 1 for all time. And 1 is always smaller than 5. So I get stuck into an infinite loop, because if I don't change I, it will keep the same value, 1, and this will be always true. And it will never stop. This is why, for the while syntax, I need to update, if not every time, every now and then. So at some point, I need to have something that stops my loop. I can set even more complex condition, like I have 2 conditions. In this case, whether the iteration is between 1 and 5, and another condition that the answer of the user needs to be yes. Meaning, in both cases, I have 2 variables determining my condition. These 2 variables needs to be declared and initialized at the beginning, because otherwise this will be false since the beginning and I will not execute anything. And I'm expected, beside other instructions that I may do, to evaluate whether to update one or both of them. So the index will be updated because I set an increment by one, and I will update as well the answer by asking the user whether she wants to continue or not. Let's write the same example of calculating the sum of a set of numbers using the while condition. So using the while condition means that we don't know a priori how many elements and which are these elements. Suppose that I'm asking the user to provide such information time by time. So answer equals to yes, because the first time. And while answer equals yes, then what I do? First of all, I need to ask the user, please give me the number that you want to insert. So input, enter the next value. Just for the sake of visual effect, I'm putting a new line. Where to store it? We know that input that comes from the standard paper, from the terminal, is always a string. We need to cast it. Okay. And let me use just a variable. Is not very indispensable, but just to make things a little bit more simple. And sum value. So I'm getting the value that the user is entering, casting it into an integer, because obviously it will be provided to me as a string by the terminal, and sum value. Okay, but we didn't change, or we didn't update the variable that drives the condition. Okay, answer equals input. I need to ask the user whether she wants to continue or not. So do you want to continue? I'm suggesting the answers. Yes, no. And as well, new line here. Okay. And that's all. Then print the sum. So basically what I'm doing, well, the answer is yes. At the first time, it has to be yes, because otherwise it will not execute at all the while loop. I'm asking the user to enter the first value. The next value, obviously the first time is the first value, but this doesn't have an index. I'm summing this value to a variable and ask the user whether she wants to enter another one. If yes, I will execute the instruction on line 6. So these three instructions are the body of the while loop and will execute every time. Let's try. Enter the next value, 7. Do you want to continue? Yes, I have another value. The next, just 2 numbers. Yes. 6. No, I have only, suppose I have only 3 values. I don't want to insert any further. Okay, it breaks and it just prints in the standard output the sum. So basically, we are doing the same thing, but the only difference with the for loop is that in this case, we are grabbing one by one, we are asking one by one the elements, and every time, as we don't know how many elements do I have, I'm asking the user to give me a hint. Another alternative could be by asking the user since the beginning, saying that, hello user, how many elements do you have? And then we can write a for loop with that range. So for example, shortly write it here, but this is supposed to be written with a for loop in the num of elements equals int input how many elements, basically how many elements. So considering that I have the number for I in range number of elements. Now in this case, I only need to ask the user, okay, give me the number. So value equals int input next value, please, and sum. Value and print at the end the sum of values. So this is an alternative by when I do not know the values of these variables, of these elements, but I know how many there are. So for considering that I know the number, I can iterate n times, and each time, obviously, I need to take this information from the standard output. Shortly, in order to resume the difference between for and while, for iterates over a set of elements that we know. Instead, while iterates under a set of conditions. So it iterates until something keeps true. For the loop while, we iterate over a set of values, and we are supposed to know the values. With while, we iterate over only the condition. And another difference between the two is that for the variable I, iter, whatever variables that we have been using, like in this case I, this changes automatically. So we don't need to increment it, or it will, so every iteration, it will have a different value, because Python will assign the value of the next item. But for the while condition, we need, as we have seen in the example, to explicitly update the values of the variables that drive the condition. Some alternatives, or some additional features, more than alternatives, to the loop, we can have a break, which interrupts the loop. In both cases, for or while, it works for both of them. And while iterating, if there are some conditions on which we don't want to go any further, we can break the loop. An example, suppose that we have a list of numbers or a list of elements in general, and we are looking for a specific one. Suppose that we have 100 elements, and we are looking for one of them. And we start checking one by one all these elements. If we found these elements among this list, there's no need to go to the end. So if I have a for loop over 100 elements, I don't need to go to the end once I have found what I was looking for. So in this case, I may have for the whole list, if the iter equals to the variables that I'm looking for, just break, because I got it. This is an example of the syntax break. So we want to interrupt the execution. Either we have written it with a for loop or with a while loop. We want to interrupt the execution at some point, either because there is a mistake and we cannot go any further. So we are asking the user to provide some numbers, is providing some text, or is providing some values that do not make sense to us, and there is no reason to continue anymore. We can use break. So any reason that forces us to either expectedly or unexpectedly interrupt the execution of our while. An alternative to the former example, we can write while true, which is basically, it puts us in an infinite loop. Value equals int input. So enter next value. Int input, so 0, 2. Okay. Here is missing. This is sum equals to value, and answer, which is the string input, and we ask the user whether she wants to continue. I keep it short. In case answer equals to yes, break. This is just an example how we can, in a different way, write, so interrupt. Obviously, we need to initialize sum, answer, there is no need, and value. Value is not indispensable because it will take the value we can declare and initialize it inside the while loop. And the next value, 8, continue. Sorry. No. So I break if I don't want to continue. So it's the reverse logic. So let me run it again. 5, yes, and the next value, 9, enter yes, and the next value, just write something. This time no, it stops. So it's an alternative to the, we can put, as in the former example, involve this variable in the while, but this is an alternative usually done for unexpected condition. Because if there is something that I planned, like in the first example, with answer is a part of the variable that I have to consider, then I can use it in the while condition. Otherwise, for any other problem that I may encounter, I just can break. Continue is an instructions that does not break the loop, but it skips the iteration. What does it mean? Suppose that I'm iterating over n variables, n values, and elements. And for some specific elements, it doesn't make sense to execute the set of instructions. And for those elements, I may skip whatever follows the instruction continue. It doesn't break the loop. It continues the iteration over an element. Let's say while, suppose I'm asking the user to enter some values, but I'm not automatically updating the sum. I will ask as well whether I want to sum those numbers. So while, let's keep it not while true, doesn't matter. Enter the next value. The first answer is, do you want to sum? If no, then continue. Otherwise, let me just take it off. So I get the value. Suppose that here I have some other instructions where I store the value somewhere, doesn't matter. And I ask the user whether to continue whatever comes after the if condition. So whatever comes later. So if this will be executed, it doesn't break. It just will skip the remaining instructions and it will continue to the beginning. So let me write it 5, because otherwise it will iterate, let's say 1 or 0. And I need to update the iteration here, because if I let it as the last step to do, if I may do it here, what happens? So here versus here. Here it will update every time that I have an iteration, because here no one stops me. But if I increment the iteration at this point, if the answer of the user is no, this will be skipped. And I will not be able to increment the iteration variable. It might be as well a wanted scenario. So I will ask numbers and stop until I have collected, I have summed 5 of them. If you want this to be the logic, that's fine. I want just to show you what happens if we write the instructions here, or so in line 6 or in lines 12, because it will have different effects. So upon what is your desire to implement, then you can write it here or here. But suppose that I want 5 iterations, none more. For 5 iterations, I need to initialize to 0. And I will sum the numbers only if required. So in any case, I'm collecting 5 numbers, but summing only once if the user explicitly is asking for that. Enter the next value, let's say 2. Do you want to sum it? Yes. Enter the next value 3. Do you want to sum it? Let's say yes. 5, no. 6. No, they're supposed to be, this is the last element. No as well. Sorry. I should have, because we don't see the effect here. Print sum. I forgot this. I will make only 3 elements in order to make things shorter. The first element is 5. We want to sum it, yes. The second element is 7. Yes, the third element, it puts 10. No, do not sum it. And as you can see, the sum is 12 because it's only the first and the second element and not the third one. The third one has been skipped. Else is a syntax, an extension of the syntax of while, basically. It can be used as well for the for loop. Such syntax is not commonly used by other programming languages. There might be some that I don't know, but so far, to my knowledge, only Python is using it. It will execute if the condition of the while is negative, so it's false. But we know that while will iterate this block once the conditions here is true. The moment that it turns false, it breaks. It breaks, but the execution of our program doesn't terminate. It continues with whatever follows the while condition. So writing these instructions using the else or without else, it has exactly the same effects. Because in the first scenario, while this condition is true, it will iterate the print and the increment, and the first moment that it returns false, it just will print the else. So whatever comes to the else. In this case, while as well will iterate print and the increment if this condition is true. Once this condition is false, because I becomes 5, it breaks and continues with whatever comes next. And whatever comes next can be exactly the same thing. So these two syntaxes are completely equivalent. And the use of else is not very common because at the end, there is no strong benefit on its use. Last topic is about the nested loops. As for the nested condition, where we had a condition inside another condition, as well here we may have a loop inside another loop. Suppose that, like in this example, we have 2 sets of elements, so the elements of the color and the elements of the shape, and for each element of the first set, so for each color, we will loop over the shapes, and if we just print in the standard output those values, we are expecting to have, so the first time X is red because it's the first element of the list, and for each element of this list, I'm expecting in the standard output the association between X and Y. So red and square, red and triangle, red and circle. The second iteration on X, X takes the value of black, the second element. And again, another loop over Y, associating the current X value, which is black, with all the elements of shape represented by the variable Y. So we will have black and square, a black and triangle, black and circle. So it's a combination of the elements of the first set and the elements of the second set. So at the end, we will find out in the standard problem something like this. We may have depending loops where the number of iterations of the second loop depends on the first. So the elements of the first loop. Here we have, so for x in a range from 1 to 5, so basically 1, 2, 3, 4, and another loop for y in range x. This will depend on the specific iteration. So the first iteration, it will be, so x will be 1, and is same as having this kind of code. So for x in range 1 to 5 and for y in range 1. For the second iteration, we will have x equals to 2 and is like having x in range 1 to 5 and y in range 2, because at the second iteration, x will be 2. So we are changing, we are binding the number of iterations upon the values of the elements of the first range. Let's just show an example here. So for I in range, let's say 5, considering as well 0, for j in range I. So instead of using x and y, I'm using I and j, but just to get stick to the example. Print x str, because this is a number, I need to cast it to a string. Just some token to make it more visual, and y. In this case, we will have 1 with 0, 2 with 0 and 1, 3 with 0, 1, 2, 4 with 1, 2, 3, 4. So 0, 1, 2, 3. We are missing a value, in fact. X has the range from 0 to 5, but I don't see any 0 in the first column. This is because range 0 doesn't produce anything, though this will not be executed. Because we know that for x in range 5 means 0, 1, 2, 3, 4. So our 5 elements. We find out here only 4 of these elements. This is because for the first x, which is equal to 0, this will be 0. Range 0, we don't have any, so because we are generating 0 values, so there is no range at all, though it will not be, it will not print anything, basically. In the second iteration of x, with value 1, it will create a set of 1 element, which is basically 0, the only element that we have. The third iteration, where the value is 2, range 2 will create 2 elements. As you can see, range 2 creates 2 elements, 0 and 1. So x equals to 2 will be associated by 0 and 1, and so on. For element number 3, I will have 3 elements, 0, 1, 2. And for x equals to 4, I will have 4 elements, 0, 1, 2, 3. And this is the output effect of this loop. This is all for today, and see you next time.